Hi, this is OrgoChemSimplfied, and here we're doing a quick problem on Keto-Enol Tautomerization. So, right now we have the enol form of this compound here. How do we know it's an enol? Alkene, alcohol. When you combine those two, it becomes enol. Right? So we want to draw the keto form. So it's a ketone. Right? So, a tautomer is when you switch the position of the hydrogen, but with besides that, the bond-bond connectivity is the same. So, we have an O, right? And we know it's a keto form, right? So it's going to be a ketone. And instead of the hydrogen being on the oxygen, now it's on that carbon, because this carbon used to have two hydrogens, right? Because it's sp2 hybridized center, and now it has three carbons because it's sp3 hybridized now, right? So we could have just left it at that, but I actually want to work through the mechanism for it. Okay, it'll give us a bit of understanding into where this all comes from. I know a lot of professors just like to say, oh, it tautomerizes. Sorry, say that 5 times really fast. Okay, tautomerizes. Where does it all come from, right? Well, we know we have H pluses floating around. It says so here. So it has to do with something with the H plus. Well, if we do this, if we pronate the oxygen, right, that's going to get us H2O plus. You know, typically you'd think that would be a leaving group, but there are no leaving groups if you have an sp2 hybridized center, right? Leaving groups only occur with sp3 hybridized centers because, first of all, you don't have that double bond there. Second of all, when it leaves, you get a tertiary carbocation, right? So that's not what attacks the H plus. We only have one other source of electrons, and that's this double bond here, right? So it's actually this double bond that attacks that H plus. Once that happens, we get this structure. So instead of 2 hydrogens here, we have 3 hydrogens because it's sp3 hybridized. And the positive charge is going to be here. Okay? Okay. So, we have a source of electrons and a positive charge here. We also know that oxygen is bigger, right? Oxygen is bigger than carbon, so it's better at carrying that positive charge as opposed to carbon, right? So, actually, it would be more stable if these electrons came down and formed a double bond there. Now what does that leave us with? That leaves us with the positive charge. Instead of being on the carbon, now it's on that oxygen. And oxygen, we know it's more stable as a ketone than as a protonated ketone, right? So again, we're going to take off this hydrogen, and what's the most basic thing we have around? Well, typically it's going to be in water. So if you usually don't have a base, the most basic thing you're going to have around is water, and that's going to take off that hydrogen and give the electrons back to the oxygen. So that's going to leave us with the keto form. Okay, so hopefully that gives you a little bit of insight on how we go from the enol form to the keto form. You know, a lot of professors like to say, oh, well, they just tautomerized, and you'll learn about it later. But I think it's good to have an understanding of where this all comes from. What's the mechanism? right? That way you'll have a better understanding. But essentially it's the same thing. It's what are your starting products? What are your starting materials? How do they interact? And what are the logical steps that happen to allow me to get to my final answer? So, please, if you liked it, like the video. Leave comments or questions in the messages below. I'll try to get back to you, and thanks for watching.